These two examples are on the slides for Newton's laws, in particular for Newton's second law. Sometimes students struggle with these because they're not quite sure how to begin. They're actually not that difficult once you know what to do. So let's look at the first one. We've got a 2 kilogram weight and a 4 kilogram weight. They're joined together by some kind of wire or string, and at this end there's a force pulling of 24 newtons. We have to work out the acceleration. Well, it's not very difficult because these two are joined by a string. As long as it's under tension, they're going to move together. And it is under tension because there's a net force pulling this side. So because they're working as a system, it's just 6 kilograms total. So all we have to do is force is mass times acceleration. 24 newtons is 6 kilograms times the acceleration. So that's going to be 24 divided by 6, may as well write it, which is 4 meters per second squared. The second one's a little bit different, only because gravity is involved. So here I have 6 kilograms, but it's going to accelerate, and we know from looking at it, it's going to accelerate this way. It's going to turn clockwise. But how rapidly will it accelerate? Well, what are the forces involved? There's tension in the string here, but it's the same as the tension in the string here. It's balancing out. There's a weight force here, which is 2 times 9.8 newtons. And there's a weight force here, which is 4 times 9.8 newtons. So that's 19.6 newtons. And that one is double that, 39.2 I think. 19.6 times 2, 39.2. So think about this. This end's pulling this way, this is under tension, and this end's pulling this way. The net force will be 2 lots of 9.8, 19.6 newtons, pulling this way. So the net force, which is mass times acceleration, the net force is 19.6 newtons. Okay? The mass is effectively 6 kilograms, and we're looking for acceleration. 19.6 divided by 6. Can't do that in my head. 3.27 meters per second squared.